Day 307 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 152, maximum product subarray. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description and get you some. Now let's see what the question says. Question says, given an integer array nums, find a subarray that has the largest product and return the product. The test cases are generated so that the answer will fit in a 32-bit integer. So now that we read the question, let's go ahead and take a look at these examples. But before we look at the example, let's make sure we read the definition of a subarray. So a subarray is a contiguous, non-empty sequence of elements within an array. Okay, so now that we know what a subarray is, let's go ahead and take a look at example 1. So in example 1, we have the input nums equals an array of integers 2, 3, -2, and 4. The output is 6. Explanation says 2 and 3 has the largest, or the array of integers 2 and 3 has the largest product, which is 6, or the subarray 2 and 3. Now it's important to remember that we have to, our products have to be, or not our products, but the numbers that we use to find the product has to be a contiguous subarray, has to be a subarray, right? So 2 and 3 works because 2 and 3 are right next to each other and can be included into the same array. Some of you might be wondering, why can't we take 2 and multiply that by 4, which will give us 8? That's because 2 and 4 will not be in the same array, right? We can't, that's not a subarray. 2 and 4 is not a subarray. 2 and 3 is a subarray. 2, 3, and -2 is a subarray. And even 2, 3, -2, and 4, that's the whole array, but we would still have to include this -2, right? So if we include the -2, it would be -12. It would be 2 times 3 would give us 6. 6 times -2 would give us -12, and -12 times 4 would give us -68. And -68 is not, that's probably the lowest number we could get, right? So we have to remember that the elements that we use have to be a subarray. We can't just pick and choose which elements we use in the input array. So that's why we chose 2 and 6, because that will give us 6, which will be the highest possible subarray that we can create. So yeah, remember, multiplying a number by a positive number by a negative number will always give you a negative, and multiplying two negative numbers, however, will give you a positive. Now let's go ahead and take a look at example 2. In example 2, we have the input nums equals an array of integers -2, 0, and 1. This time the output is 0. Explanation says the result cannot be 2 because -2 times -1 is not a subarray. So once again, just like we had up here, 2 and 4 would not be a subarray. Same thing over here. -2 times -1 would not be a subarray as well. And anything multiplied by 0, as you know, is going to equal 0. So 0 is the largest, or the maximum product that we will be able to create. Now that we understand the question, y'all, let's go ahead and take a look, let's go ahead and get into this actual code, the solution, y'all. And the solution's not that difficult, so let's get started into it, y'all. So the first thing we need to do is we're going to create an edge case. If the input array is empty, then we could just return 0. So in order to do that, we could just come right here. We could say if nums dot is empty. We could just open up the brackets and we can say return 0, just like that. Now we need to initialize some variables which will help us track the maximum and minimum product subarrays ending at the current index. So in order to do that, we could just come right here. We could declare a variable called cur_max and set that equal to nums 0 to start. Same thing, we could declare another variable, this time called cur_min. We could set that to nums square bracket 0 to start as well. Then we come down here, we could declare another variable called ands and set this equal to the cur_max. And this is going to store the final maximum product found, right? So the cur_min, that's going to track the minimum product ending at the current index. And this is going to track the maximum product ending at the current index. So now we need to iterate through the array so in order to do that, we could just come right here. We could say for I in one dot up to nums dot count, open up the bracket. This should be for I, boom. For I and 1 up to nums dot count. Now we need a current number in the array. We need to store the current number in the array. So we could come right here. We could just say let cur equal nums square bracket I. Boom. Now we have the current number. Now we need to calculate the maximum product we need to consider the current number by itself. We need to consider the product of the current number with the previous maximum product, and we also need to consider the product of the current number with the previous minimum product as well. So in order to do this, we're just going to say let temp max equal, open up the parentheses, cur, comma, cur times max, cur times cur max, comma, cur times cur min. Boom. Now we need to keep track of this cur min for when we're dealing with negatives, because remember, if we have two negatives, right, two negatives can get us a positive. So that's why we need to keep track of the cur minimum as well. So now we need to update the cur minimum, which will in order to track the smallest product, because just in case, once again, we multiply a negative times a negative, that can get us a positive. So we need to keep track of the current minimum as we continue. So we're going to say cur min equals min, open up the parentheses, we're going to say cur, comma, cur times cur max, comma, cur times cur min. Boom. Now we need to assign the tip max to the current max. Excuse me, y'all. Since the current max will be needed to calculate the current min. So we're going to come right here and we're going to update the cur max to the temp max. So we say cur max equals temp max. Because remember, this cur max needs to be up to date for when we are using it up here. Boom. So now we need to update the final answer with the maximum product that we have found thus far. So in order to do that, we could just come right here, say ands equals max, open up the parentheses. It's either going to be ands, comma, cur max. So once again, oh, sorry, y'all, this should be a max right here as well. So once again, y'all, this right here is going to give us the maximum value of either cur times cur max, or cur times cur min. Whichever one is the biggest, that's the one that's going to return. Similarly with this, this is going to return whichever is the smallest. Same thing, whichever is the smallest. That's what the min is for. It's going to either cur times cur max or cur times cur min, and this is going to return whichever one is the smallest and stored in cur min. This one's going to store it in temp max, but then we're going to update cur max to temp max down here so that cur max can have the updated value as well. So now that we've done all of that, we're not done yet, because we still need to return the maximum product subarray that we have found. So we're just going to come right here and we could say return ands, just like that, y'all. So that should be all she wrote. Let's go ahead and give it a run, see if it runs like it's supposed to. Can we get the first try? Yes, we can. Look at that, y'all. So let's go ahead and submit it. Make sure it still works after we submit it. Oh, that's what I'm talking about, y'all. 0 milliseconds beats 100% of users with Swift. That's what I like to see. Not too bad at all. So before we leave, y'all, make sure you get one more look at the code. Read it, learn it, love it. Make sure you understand it and internalize what is going on here so that you can use the knowledge that you've gained here in future LeetCode problems. This is the top half. Go ahead. This is the rest of it, not that much. Then that's the bottom half. And yeah, with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.